All right, I'm gonna make this video and go over the test, and I will the multiple choice. I will just go over my key, and then I'll switch over and actually work out some of the questions if if I feel like I need to. So here we have which pairs of angles are equal in the diagram. So you kind of had to almost eliminate the ones that weren't, right? So you go through every single one, and as soon as you notice something isn't adding up, then you move on to the next. So B is the answer there. For number two, B was the only one that made sense. For question three, D, these are not equal to each other. F and A, they're not even connect, right? I mean, they're parallel lines, all right, but these, we don't even have a name for them, right? So D is the one that is false. Which of the angle properties tells you that DEB is equal to 73 degrees? And that is B, alternate interior, right? Because DEB, right? DEB is this angle right here. So alternate interior tells you that that is true. And then five, which one proves that QDE? So you have QDE, this one here, that it is 120, right? And that would be alternate exterior. So there's your 5 marks on that page. And then the backside, which one does not is not parallel? So the first one only, that would be that. And same here for 7. You basically the best thing here is probably to fill in the values as you go, right? And then see which one matches, right? You can eliminate the first two right away because there isn't any there. You wouldn't even have a 77, so the first two are gone. So it's really between C and D, and C is the right one. 8, the sum of the interior angles. We have N as being 11 here, and so it'd be 1620. There's 11 sides on that one. Which of the following could create a tiling pattern? That one, a lot of you thought it was the exterior angle you had to find there, but it is really the interior. Okay, so you use the interior angle of that shape. So 360 divided by 120 is exactly 3. Here you have 3.33. Octagon is 135, right? That's 2.6. So these ones do not work. So it's hexagon is the only one that works. For B, part B on page 3, I'm going to switch over here and use some highlighters perhaps. Okay. So here, um, maybe one thing that would definitely help here is to maybe just put numbers next to, so FBE, right? FBE, that's, I will call that angle 1. So you kind of make a reference there for yourself. ABF, that's, I'm going to call that number 2. EBD, right? EBD, this is number 3 for me. You can use letters as well. BDE, so BDE, I'm going to call this angle 4. ABE, that's these two combined here. So I'm going to just say, right, 1 plus 2, that is. Right, if I add 1 and 2 together, I have that whole angle formed there. Okay, so let's, then I start. And no justifications needed here, but you have to do some thinking to get this right. Okay, so the first thing that I guess where you start doesn't really matter, but I know that if this is 52, right, if I travel along this parallel line, that's a transversal and it goes over. So I know that this one here, which I called 1, is 52 degrees. And the reasoning would be alternate interior. I didn't ask for it. The second one here, this angle, which I called number 2, I'm just going to use a straight line property here, right? And that gives me 55. EBD, right? which I called number 3 here, there I am going to use, you can use a straight line there if you want, like if you, yeah, you do know 1 already. So if you want to use this straight line property, these 3 angles all need to add up to 180. So you could use that property there, right? So for question 3, you go 180, if you want to put it down here, 180 minus angle 1 minus angle 2, right? You get 73 degrees there for that one. Was there another way of doing it? Yes, there would have been another way. I'm just going to stick with that. Number 4 this here, sum of a triangle. So that would be 55. So you basically go 180 minus 52 minus angle 3, right? To get that. So it's sum of triangle if you want to make note of that in your, that'll probably be a good idea to write down how you got it there. 1 plus 2, I'm just going to add those two together, and that's 107 here. Okay, because that's the whole angle that they're asking for here. Okay, so that's that. So 3-letter notation, I'm testing your knowledge on that there. And so given that AB is parallel to CD, so just to reiterate, right, these two are parallel. And notice that they're also making markings here. Okay, they're telling us that this is an isosceles triangle. And so that's very important, right? So isosceles. So if this is 65, then this is 65 also, right? Automatically, because the base angles across those sides will also be. So I will go ahead and write down 65 here right away. Base angles are congruent, right? Something like that. 1, right? This is a straight line here, so that would be 115. You just subtract 180 minus 65 to get that. Question 2, vertically opposite, or whatever you want to do there, 65. Question 4, along a straight line or vertically opposite to 1, so that's 115. 5 would be, question 5 is just sum of a triangle. Okay, so it's 180 minus 2 times 65, so that's 50 degrees. I will just say sum of triangle. And question 6, or angle 6, I should say, I used alternate interior, so that'd be 65. And 7 is along a straight line. And if you add that up, if you go 180 minus 6 minus 7, right, 180 minus angle 6 minus angle 5, I should say, right, I get 65. Straight angle. Okay, so that's how you did that, those questions, and half a mark for each. And then we got to this point. Okay, you had to show that, right, are these two lines parallel? Okay, and the base idea here was to find what this is and find what that is, and we know a name, right? They're consecutive interior angles. Okay, so that means that they add up to 180. If they add up to 180, the name is consecutive interior. If we can show that they add up to 180 or are supplementary, boom, we're done. Then these two lines are parallel. You cannot use corresponding, because if you wanted to use, right, we would need this whole thing here would be corresponding to that, but we just have that sliver there. So you couldn't really do that. Some of you got a bit creative there. So x is just going to be 5 minus 2 times 180 over 5, and that's 108. So I've established that this is 108 here. To find this, you had a couple of options. You could have used the trapezoid, right? You go 360 minus 2 times 108, right? If you want to call this B or something, to get B, we go 360 minus 2 times 108 divided by 2. And so this is 216, and we get 72. Yeah, 72. And so we put down 72 degrees. Since, or A and B, or sorry, angle B and angle X are supplementary, and consecutive interior. Remember, to show that something is parallel, name it and say what should be the case. Are they congruent? Are they supplementary? Therefore, AB is parallel to CD. So that's how you would prove that. You could have also used the triangle, right? 180 minus 108 up here, divided by 2, you get these two slivers. And then you have to go 108 minus that sliver to get 72. So regardless, you would have had 72 there and making them supplementary. Okay, next page. I have to kind of hurry because class is going to start soon, actually. So maybe I'll have to make this a two-part. So for question 4 here was a little tricky. So to get A here, I used the fact that 75, that whole angle, is the same thing as this whole angle here. Okay, so if this 75, this whole thing is 75 here. Therefore, if this is 75, A is going to be 75 minus 22. So we go 75 minus 22, which is 53 degrees. And I use alternate interior angles. That's really how I got this, right? So this is 53 degrees. B, now that I have A, I have sum of triangle, right? So 180 minus 45 minus A, right? And that gives me 82 degrees. And I just use sum of triangles 180. So that's 82. And C, you can use the straight angle property because now that you have B, right, that all these three are along the straight line there. So minus 75 and minus B, and that will equal to 23 degrees straight angle. Are there different ways? There are probably more ways. And then D, you could say consecutive interior or something like that. Consecutive interior, 275 degrees, right? These add up to 180. So there you have that. And this one, these three, right? X plus 1 plus 2x plus 62, it should add up to 180, right? That is the truth there. You distribute this, a lot of you forgot that. Okay, and then this gives you 5x here plus 3 is equal to 180. Sorry, plus 3 and 62 is 65. Sorry, is equal to 180. 5x is equal to 180 minus 65. 5x is equal to, this gives you 115. Dividing both sides by 5, x gives you 23 degrees. So that's what you were supposed to get there for x. This one was done fairly well. I will just show you how you do that one. You essentially find the sum of the interior angles of a nonagon, which should be 1260. You take 1260 and subtract all the angles that you're given. So the one left is 139. Okay, so that's how you did that one. 7 was done fairly well. I'm just going to show you the answer key to that. So finding the interior angle rounded to 2 decimals, and you're supposed to find 2 ways of finding the exterior angle using the formula and by subtracting the interior from 180 to get the exterior. 8, determine the number of sides. There are 2 ways of doing that. I think this is the long way. If you need to make sure you get rid of the n, you multiply both sides by n, leaving you with 156n on the left side, and on this side you multiply out the 180, giving you 180n minus 360. Then you bring the 180n over the equal sign, make subtracting, you're left with negative 360. This gives you a difference of negative 24. You divide both sides by negative 24, you get 15. Or you do it the easier way, which is also in your notes, right? So 15 sides. Guessing would not have been enough there. And then the tessellation question, you have octagons and squares. You need to work with the interior angles. So you'd start with 360, you subtract each one of them once, and then see what else still needs to be covered. And it ends up being 135 that you still need to cover, so you need another octagon to get it down to 0. So yes, you can tile the floor with 2 octagons and 1 square. Do not use exterior angles. A lot of you used exterior angles there. Okay. This one, hopefully the bell is going to go, so don't mind it. This one, what you had to do here is find the interior angle of that heptagon. Okay, it was a heptagon, n is equal to 7, right? So B here is actually the interior angle. So it would be I of 7, which would be 7 minus 2 times 180 over 7, and that gives you 128.57 degrees. Okay, 128.57 degrees, and it's the interior angle. That would have been your starting point for sure. And then to find C, for example, you have a trapezoid here. So go to the trapezoid. That would be 360, because that's what a four-sided shape adds up to. You have 128.57 here, 128.57 there. So it's 360 minus 2 times 128.57 divided by 2. If you do this right, you get 51.42 degrees. Okay, and then to get D here, you can just take, knowing that this is 128.57, the whole thing, I will subtract C from it. So that's 128.57 minus 51.42, and that gives you 77.15 degrees. There's another way of doing that using the pentagon here. And then A, you need to find, these are both exterior angles here. These are both 51.43. 51.43. So A is really 180 minus 2 times 51.43 degrees, which gives you 77.14 degrees. Okay? So that is your answer there. And then over here on the back side, I will just show you that what you were supposed to do here is find the equation for length in terms of the width. And one second, this video. So then you get, this is really the perimeter. So there are 5 widths. A lot of you put 4 down. So it's 1500 minus 5W. That's what you write down there. And then you plug in the values. You figure out the length given the widths here. Yes, you get 0, which is actually 0, folks. And then you come up with the quadratic equation. That will give you the, you're supposed to find the vertex, which gives you the length that will give you the maximum area. and then you divide those two to get the width. So the dimensions are 750 by 150. And then there was that last question on finding the solving this equation using the quadratic formula. These are your coefficients. When you plug them in here, you get negative 0.4 and positive 1.9 doing it that way. Okay, that's it.